iteration, then post2 may or may not be true, but pre1 has to be true. Okay, so that's that little circle thing, and there's no easy way to put it, unfortunately. No, I can put it here and then just draw a line to link it. There we go. All right. Yeah, that works. What about post 3? We know it is post 3, but we want to express post 3 in some other forms. So what do you think post 3, should be like? Okay, so we know one thing. Okay, very good. Let's start with something that we know for sure. Not C has to be true, because otherwise we wouldn't be exiting the loop. What else do you think can be true? Pre1, because we may not even enter the iteration once, so we may not have gone through even one iteration. So pre1 can still be true at this point. What else can be true here? If we go through at least one iteration, so what has to be true at this point? Post2. Okay, so post2 is also true. All right, so we have done pretty much as we can do just by looking at the general structure of a loop is this. Okay.
I have a question.
Yes?
Why can't it be pre1 and post2?
Because we don't know which way we came through or came from, so it cannot. Okay. Once again, it's kind of like the merge of a conditional statement. So you're standing up at a point after the merge, and you cannot remember which way you came from. So the only thing you can say is at least one of those two conditions has to be true, but that's all you can say. You cannot say both have to be true.
So we use or just because it's not as exclusive as and?
We use or because, okay, let's see how we can
condition can be true, not both conditions have to be true.
Right. At least one has to be true. They can both be true,
but at least one.
At least one has to be true.
Whereas an and is both of them have to be true.
Exactly. With an and, both of them have to be true, and this we cannot guarantee that here. Yep.
So for post 3, so it has to go through one iteration before it hits post 3 and it has to go through.
Well, when we get to post 3, we don't know whether we have gone through at least one iteration or not.
That's saying right there. That is post 3. That split right there is saying you can bypass the condition.
Exactly. Yep, exactly. The split is here. Okay, the split has to do with this part here. In other words, we can go from here and all the way out. Or we can come here and have this merge before we get out. So that's why there is a merge, and whenever you have a merge, then you're looking at a disjunction, because after the merge, you don't know which way you came from. And as a result, you can only say that one of the two has to be true.
That's why you have or post 2.
That's why we have
Or post 2. After
exactly. That's why we have an or post 2 here, because we can come through here without going one iteration, or we can go through at least one iteration so that post 2 is true. Yep. Okay, very good. But this is kind of tricky, because how do we get pre1 is easy. Pre1 has to be given, right? The precondition of the entire thing has to be given, so otherwise, we wouldn't be able to do any type of processing. This one here is tricky already, because C is easy. Okay, C is also a condition that is already specified in the code. But post 2 is tricky, because what we are looking at here is pre2 depends on post 2, because it's a loop. Is that making any sense? What we're looking at here is this entire thing here is also known as pre2. Okay, let me just go in and make that change. Pre2 is the following. And now we have a problem, because if that is pre2, then potentially post 2 can depend on itself. So how do we resolve that? That's the big question. So there's no universal way to do this. This really has to be done on a case-by-case basis. Do you guys see post 2 appearing in multiple places? Because this is post 3. Post 3, does contain, does mention post 2 too. We see post 2 here because that really is the post condition of line 2. We see post 2 here in pre-2. In other words, the precondition of line 2 potentially depends on the post condition of the same line. We also see post 2 here as the entire loop exit. So post 2 is everywhere. Yep.
So why do we just, how do we know it's going to be a problem? That's what you're saying, right?
Well, we know it's a problem because we can no longer just go in one direction and do the derivation that way. Because up to this point, even with conditional statements, I can still use the forget rule or the substitution rule with an assignment statement. So if you give me the precondition, I know how to get to the post condition. In this case, it is a lot more difficult because the precondition itself, it also has the post condition of the same line as a component.
So that is going to automatically problem.
Well, it can be solved, but it cannot be solved using the techniques that we already know. Yep.
Where are you getting pre-2? I understand where you go to pre-1, but where's pre-2 coming?
Pre-2 comes from the fact that this is line 2. Line 2 is the statement that we are executing in the loop. So this point here is pre-2 because it is right before we execute the statement, and that's why it is labeled pre-2. Yep, go ahead.
Shouldn't pre-2 be labeled post 1?
No, we don't refer as post 1 because because after line 1 we are not guaranteeing to get to line 2, and that's why line 1 and line 2 are not considered sequential anymore because one does not automatically lead to the other one.
It's definitely not sequential.
It is not sequential because there's a way to branch. Yep. All right, so let's take a look at this picture again, and then what we'll do is we'll work on a very specific case so that we can see, okay, given something like this, nasty, can we still figure out what is the post condition of the entire loop? Because we certainly hope that we can do that, right? Okay, so what we'll do is we'll work with one specific example, and we'll say, while x is less than 3, do, and I'll simplify this a little bit too. X gets x plus 1, line 3, and while. And you know what? I'm going to make this a little bit easy. I'll just say that before the entire loop, I know x equals to 0. Okay? So because that really does help to make this a little bit easier to understand. Okay, if I know that x equals to 0 before line 1 executes, so let's go ahead and look at some of the other stuff here. Let's go to pre-2. So according to the picture, pre-2 is C. Now C is x is less than 3, right? And then we have post-2. Post-2 is still post-2 because we don't know what it is. Or pre-1. Pre-1 is x equals to 0. Is that part okay? I'm simply plugging in specific information from this particular pseudocode into the template that we have seen in the picture. Is that okay? All right? Okay. The next question is, can we simplify this a little bit here? Is there any way to simplify this expression even though we don't know what post2 is? Well, let's see whether we can do certain tricks that we already know in algebra, okay? In algebra, there's a distributive rule, right? W times y plus z is wx plus wz, right? We have something like that too in Boolean algebra. So I'll just kind of work this out first. The claim is, if I have A, B, and C, and then I have the expression A and B or C, my claim is this is the same as A and B or A and C. That's my claim. How do I prove something like this? The truth table, exactly. Truth tables are very useful in Boolean algebra because it can be used to prove theorems just like this one. In normal algebra, when you deal with integers and real values, you cannot use a table to prove it because there's an infinite number of values for each independent variable. In this case, it's limited. Okay? How many test cases do we have in this case? How do we exhaustively test everything? 8. 2 to the power of 3 is 8. That's because A can be true, it can be false. False, false. While A is true, B being independent can be true or false. While A is false, B being independent can also be true or false. When A is true, B is true, C being independent to the other two can be true or false. So you can see the general pattern here. Right? I'm not going to work this out. I will leave it up to you guys to fill in the table because you should be able to fill in the table now. So when you fill in the table for this column and then fill in the table for this column, you should end up with these two columns having exactly the same value on each row. Okay, but I'll leave it up to you to verify that, okay, because we don't have enough time to go through this. I'm just claiming that the distributive law also applies in Boolean algebra. Okay, so let's see why is that even significant in this case? Because it seems like, it's not going to be very helpful to us. X is less than 3 and post 2 is 1, and then we have x is less than 3 and x equals to 0 is the other one. Okay, is there any simplification here?
Factor out that x is less than 3. That's essentially just going backwards.
Well, this one we cannot simplify at all because we don't know what post 2 is. So we'll just have to keep it the way it is for now. What about the other side?
Say x is less than 3 because x equals to 0 is true.
Well, when you have a conjunction, you have to pick the more specific one. Okay, the first question, okay, go ahead.
X equals 0.
X equals to 0 is the end result. Okay, but why is that the end result? Okay, let's think about this. Does one imply the other one? Okay, let me point out which two we are talking about, and then you guys can tell me, does one imply the other one? One is saying that x is less than 3. The other one is saying x equals to 0. Does one imply another one? Okay, one does imply the other one. This one, x equals to 0, implies x is less than 3. Does it work the other way around? Does x is less than 3 imply x equals to 0? No, it does not. So what that means is one is quote unquote bigger than the other one, or one includes the other one. Now, when you have cases like that and the two are joined by either conjunction or disjunction, then you can choose one or the other. Now, which one you choose depends on whether we have conjunction or disjunction. Conjunction means we want to make the whole thing more restrictive, which means if one is bigger, it contains the other one, we want to pick the more specific